Good morning students, myself Badi Alekhya, Assistant Professor, AIML Department, RMD Engineering College. Today we are going to discuss the concept of planning and what is the importance of planning in artificial intelligence. So planning. So in the initial units we discussed that for executing or for solving any problem we need some set of actions. So like that planning is arranging a sequence of actions to achieve a goal. For example, if I want to I want to perform any operations. For performing that operations I implemented some sequence of actions. That things we are nothing but planning. In general terms we will tell if I want to complete this task I put a plan for that. So means that for completing that action I follow some sequence of steps. So that type of concepts in general terms we call it as planning. In artificial intelligence also the same technique. For achieving any goal we produce some sequence of actions, that one we are called it as planning. So in AI, NLP, computer vision, for example, if I want to perform some machine translation, it follows some sequence of steps. For image segmentation, for image classification, recognition, detections, that this and all things we follow some sequence of steps. So that reasoning will be needed in the planning will be needed in the artificial intelligence. So see, I see movie. Here what is agent and what is object now? So I have to represent to the mission in a sequence of ways to understanding the meaning of the particular sentence. Here I means it's representing one thing, one agent. So C means some action. So what is the thing, what is the object here? It's a movie. So I have to perform some action to do some thing. That means here to do something is nothing but I see the movie. I want to see the movie. I have to do some see action here. So like that planning will plays a very important role in techniques. So especially this planning will be useful in syntactic semantic representation and remove lexical ambiguities and define post taggings, and mainly in NLP applications planning will plays a very important role. So here one of the concept behind planning is stripes. The full form of stripes is Stanford Research Institute problem solver. So first they introduce one problem, how the mission will behave like human, how mission will solve the problem like human. So it's mainly represented by first order logic. So already we discussed in the previous units and previous sessions. The same rules here also we are going to implement under the planning of stripes. Forward chaining, where we heard this word in the resolution topics of our previous sections, we hear that forward chaining and backward chaining mechanism is nothing but if you are implementing based on facts and rules, what are the things you know, if you are providing some conclusion, some solutions to the mission, that one we are call it as forward chaining. But you have a solution but you don't know where the which type of rules and facts you are going to apply for the algorithm. Now at that place we have to use backward chaining mechanism. So based on goal, if you are going to derive some mechanisms, now that one we are call it as backward chain mechanism. And based on data, if you are going to provide some conclusions to the given data, now that one we are called it as forward chaining mechanism. So here some of the data sentences which will be understandable to the missions. Here man of X is mortal of X is some of the predicate logic. We are going to represent predicates in this form that we already discussed in the third unit of our syllabus. So it's a man of Shakespeare, mortal of Shakespeare. It's nothing but in sentence we are represented as Shakespeare is a man, Shakespeare is mortal. In that way we are going to represent. In forward chaining we have to implement like facts, rules and then conclusion. In backward chaining we are going to implement conclusion, rules and then facts. So this is a stripe problems. It's a block word problem. Mainly the children will play in the home. How they place their blocks one by one. They have to arrange in the sequential order. So like that, for example, if you are considering here this block worlds problem, on top of here C is present. The goal of the what's our goal is we have to place on top of C we have to place B, on top of B we have to place A by using mission hand, is a robot hand. Here we are performing some sequence of actions. So in the initial slide I mentioned that what is planning. The planning is a sequence of actions performed to reach the goal state. This is our goal state. For reaching this goal state, if I am performing some actions, that one we are called it as planning. So here grab C, pick up C, place on tables, these are all options. These all set of actions will be useful for use will be used to reach the goal state. That is nothing but planning. So initially when we are teach to the robotics or missions the logical reasoning, we are using this blocks word problem. So these are the fundamental assumptions. We are seeing this pick-upping, holding. So what are the actions? So first we have to pick up that block and we have to hold that block and put down onto the flat surface. So these are some of the actions. Stack, unstack. Now we have to hold and you have to clear. So unstack is nothing but we are going to perform some deletions. You have to remove from one end and you have to place it on. We have to unstack from one end and we have to stack to the other end. So already see these are all the sum of the actions in triangular table they present. So it generally you can see, but the when generally you know first we have to place if you look at the previous diagram you clearly understand. First we place all the things on the flat surface and we have to place on top of A you have to place B, and again the next action on top of B you have to place C. General human they can have a sense to know what is the next step we have to follow and what is the other step we have to follow. For mission we have to give some predicate rules to solve the given problem. So these are the some of the rules given to the mission when they are solving. So this is the basic introduction regarding planning. We have different types of planning: hierarchical planning, probabilistic planning, and constant satisfaction. This constant satisfaction is already we discussed in the previous sessions. So I'm just giving a brief introduction what is planning and initially how the humans train the robots by using some black words problems. Is just a brief idea. Thank you students, we will meet in the